Hello everyone. In this video I'm going to explain you the PPT. I'm going to show you 20 minutes of demonstration video. So the project execution and the demonstration will be followed in a different video altogether. So let's get started now. So the title of this project will be MapReduce Scheduling in Shared Environment, or any other title which you are using, anything will be the same. So for the title justification, you can say MapReduce is the algorithm or the technology what we are going to use for developing the weather analysis, log analysis, and the frequency count applications that will be executed in Hadoop. And scheduler is another name for a planner application what you people have built so far. And the meaning of shared environment is the Hadoop environment, which comes by default with Altenworks Sandbox. So there you would have seen the concept of data nodes and the name nodes. So the primary memory and all the other external resources will be shared across these data nodes and the name nodes. So which will be provided by Hadoop environment itself. So the name shared environment. Okay. So these are the items that we are going to see now. The problem statement, existing system and their drawbacks, the proposed system and their advantages, use case diagram, data flow and architecture diagram, followed by module-wise explanation. Okay, let's get started. So the statement of the problem can be divided into three major parts. The first one being RDBMS, which is incapable of processing large data sets. So to speak something about this, we all know that RDBMS is a relational database. So whenever we say relational database, it stores the data in multiple tables with relationship between each tables, right? So for instance, if you say there are a student table, a department table, and a project table, and a library table, 4 tables to store 100 students information. So if each table contains 10 rows, so joining all the 4 tables will be giving you 10 into 10 into 10 into 10. So which happens to be 10 lakhs rows, right? So just to retrieve 10 students information, you are processing 10 lakh rows. So that is the complexity of the relational database what we are going to use till now. So we say that RDBMS is only capable of processing only small data sets or medium scale data sets, but definitely not large data sets. So we cannot go for RDBMS in case of processing huge data sets, right? So, but the problem what we are considering in this project is very huge data sets. Okay, like we do have 1 GB of data, 2 GB of data, 10 GB of data like that. So we need algorithms to process that huge data sets, right? So definitely RDBMS is not a solution for us. Okay, so I can put a tick mark saying that, so this has been done. So the complexity in performing analytics, right? So even though we have collected a huge amount of data sets, there is no readily available algorithm or the solution to process it. Say for example, I collected a huge amount of information regarding the visitors of our website. So I own my college website. I have the list of all the users who visited my website and the timestamp at which they visited. But I don't have any readily available tool or the algorithm or the technology to process that. I mean, to gather some report from that. So for example, I wanted to know in between 12 p.m. to 1 p.m. how many visitors visited my site. I don't have any solution. I don't have any algorithm to do it. All I have is the data. So who visited my website and at what time they visited. But I don't have any tool or I don't have any solution to process that huge amount of data. So that happens to be the second problem statement. So the third problem statement being no freely available efficient scheduler to depend upon. So meaning what, so if we have come up with the tool to generate the report out of the huge amount of data that I told you earlier, any user who wants to generate the report, he will have to run that tool we are going to create every now and then. So every time he wants to know the result, he need to run that software every now and then. So for example, I want to know how many visitors visited my website in between 12 to 2 p.m. today. So I need to run that algorithm today. So if I want to know the same report tomorrow, I need to run the same algorithm tomorrow also. And if you want to know the result day after tomorrow, I need to run that algorithm again day after tomorrow. So every time I need the report, I need to keep on executing the algorithm or the solution what we are going to give. Okay, but that happens to be the third problem statement. So what we are going to do is we are going to build an efficient planner so that the users can schedule it, and every day we are going to run it automatically. So user doesn't have to come back to us to run the algorithm. So we do it on behalf of them every day automatically. So that's the meaning of the scheduler. So this is about the problem statement. So let's get proceed. And the existing system happens to be the RDBMS. So the first existing system for us is the RDBMS, so which will be used for analytics purposes, which we have learned already. So the job schedulers, we have some existing schedulers like cron, extensively used in Linux environment, timer provided by Java community, and Quartz. So it's an API built on top of timers, but it's the paid version of it. So these are the existing system. So if you want to look at the drawbacks of this existing system, we say the difficulty in analyzing large data sets. So this disadvantage is for RDBMS. So we cannot use RDBMS for analyzing the large data sets. The reason because we told you that RDBMS is suitable only for small scale and medium scale application, but definitely not for large scale application, because it maintains the data in multiple tables and each table will be related to one another table, and it provides huge amount of data to process, which definitely takes a lot of time. Okay, so the second disadvantage being one analysis report can be generated at any point of time by one instance. So we are maintaining only single database, right? So we can have only one algorithm that is accessing that database at any point of time. So for example, if more than 20 people wants to access that database and to generate the report at the same time, so definitely DBMS will not be a solution for that. So existing planners like cron, Quartz, timer, so they cannot be reused, because API is just an expression that is used only in Linux terminal. So we cannot integrate that within Java applications. Timer API is just a Java API used to schedule some jobs recursively. But what if that job got missed or failed? We cannot control over it. And the third one was Quartz, right? Quartz is a paid version of it, so nobody can readily reuse it for their personal use, right? So the next disadvantage being failed task remains failed, missed task remains missed. Meaning what? The meaning of failed task is, say for example, you have scheduled a job at 3 p.m. The server turned off at 2:55 p.m. itself, and the server came back only at 3:05 p.m. So in that exactly 3 p.m., right, the server was turned off. So we call that as a missed task. Okay, the task has been missed. So none of the existing planners will be bothering to pull it back. So it will just forget about it. So that's what we call missed task. Okay. So the meaning of failed task is what, at 3 p.m. assume that the task has been started. The execution has been started, but it has never ended. The task has been started, but due to some external factors, it never ended. So we call it as a failed task. Okay, none of the existing planners will be bothering to take care of this. Okay, so and no user notification regarding the status of the analysis. So definitely there will be no email or the message sent to the user when who scheduled the job. So user will be kept isolated from the result of the job. Okay, these are the disadvantages of the existing system. So let's speak about the proposed system. So we are going to propose three main components in our project mainly. So the first component is what we generate an analytical engine. So the analytical engine we are going to develop, right? So we are going to perform three types of analytics through this engine. So one being the frequency count. So given an input file, we find out the word by word repetition count. So second one being the log server analysis. So it could be any log, say your college website log, Facebook log, Wikipedia log, okay, any website log. We are going to analyze it and we break down the hourly wise usage of that website and we generate a report. And the third, analytics we will do is the weather data analysis. So weather data analysis is, it will accept an input file, the weather data input file, and we find out the city having the highest temperature and the city having the least temperature at any point of time at any date. So we do that analytics. So it should be 3 problems. It's not 2. There has been a mistake here. It should be 3 problems. So the first problem is the frequency count. The second problem is the log analysis, and the third problem will be the weather data analysis. Okay, so I'll tell you each and everything in detail. So the second component what we are going to develop is the planner engine. So through this planner engine, we can schedule any of these analytics at any point of time in any recursive manner, say daily, weekly, monthly, whatever it is. And we develop something called helper component. So the meaning of helper component is this acts as the medium that ties this planner engine and analytic engine together. So through this helper component, so you can make this planner engine communicate with this analytic engine very easily. So the specialty of this helper component is it will be developed as a pluggable and reusable component. So meaning, so we solve this problem in 3 areas, right? The frequency count, the server analysis, and the weather data. So somebody who wants to enhance our project at later point of time can still use our same helper component. So it can be reused, and it is pluggable for any application, not only this MapReduce application, any application it can be used. Okay, so these are the 3 components we are going to propose. So the advantage being it will be taking less time during the analysis phase. Say if the traditional RDBMS and the Java programming takes 20 minutes, so our MapReduce application will be taking only 5 minutes. If traditional Java application takes 1 hour, our MapReduce program will take only 8 minutes. So it's just a rough idea. So where we are extensively saving lot of time. So we do make an asynchronous call for MapReduce programs. So meaning, so more than 1 call can be made at any point of time. So more than 1 job can be executed at any point of time, which in turn in the existing system there was only 1 job being executed at any point of time. So we are developing this helper component which is independent either from analytical engine or the planner engine. So it can be plugged into any other components. So the planner engine is reusable. Okay, the same planner engine can be used to plan any of the jobs. Right now we are planning weather data, server analysis, and the frequency count, but the same planner engine can be used to plan any other job. So customizable planner engine. The meaning of customizable is as the user wishes whether he wants daily, weekly, monthly. So he can choose whatever kind of recursive fashion he wants. And the last one is user notification. So we do send an email notification to the creator when we have planned the job, just to intimate him that his job has been completed or failed, something like that. So these are the advantages of the proposed system. So let's go ahead and understand these diagrams now, the use case diagram, the data flow diagram, and then the architecture diagram. So this is the use case diagram of this project. So if you can see, there will be 2 users for our project, one whom we call the user and one more guy whom we call as an admin. Okay, so the admin will be accessing the Hadoop environment. So this entire thing is an Hadoop environment, so where he will be able to start the Hadoop and he will be able to stop the Hadoop. Okay, so inside that Hadoop environment itself, we'll be deploying the log server analysis and also the weather data analysis. So there comes one more component, so which is missing in this diagram. So you need to write it as frequency count. Right, so these 3 applications will be developed using MapReduce programming language, and it will be deployed in this system. The system refers to the MapReduce. So all the 3 things will be developed using a MapReduce algorithm, and this whatever I have highlighted right now is an Hadoop environment. So sorry for this, it's an Hadoop environment. Okay, so if you can look at the user end, user will be accessing this shaded area. So this shaded area is what we call the planner component. Okay, it's a dynamically built web application deployed on JBoss environments. So you will be accessing through a web browser. So through a web browser, you will be accessing this planner component. So through the planner component, you can register himself as a new user. You can log in and log out himself from our project. You can plan a new job, like creating whether frequency account or server log analysis or weather data analysis, anything he can create. So he can perform the analytics of that. I mean, he can see the result of that, and he can list out all the previous result. So using this component, he will be creating a new job. Using this component, you will be seeing the result of the job. Using this component, you will be seeing all the previous result of the same job. And manage account is just to delete his account or edit his profile, like that. So here comes the reusable helper component, which actually ties this planner and this Hadoop. Okay, it is a medium which ties this planner and this Hadoop together. Okay, so this happens to be the use case diagram. So now let us go ahead and understand the data flow diagram. So if you look at this data flow diagram carefully, so we have three components here. We have an Hadoop cluster, we have helper component, and we have planner application from right to left. Okay. So what comes inside Hadoop cluster is the name node and data node that comes along with the Hortonworks sandbox that we are going to install. Along with that, it comes an administration console where we can see the status of the name node and data node, like what percentage of the data node has been used and what percentage of the data node has been remaining. All those things and all you people can see using the admin console. So what we are going to develop is the analysis using MapReduce application. So this is what we are going to do, whereas the other three will come along with the Hortonworks sandbox. So what kind of analysis we are going to do using the MapReduce application? We are going to do weather analysis and we are going to do the temperature analysis, both, right? So, and also we are going to do frequency count. So the frequency count literally has not been shown in any diagram. So if you want, you can update it or you can leave it as it is. So what Hadoop understands is only MapReduce. So this weather data analysis will be developed using MapReduce application. So every MapReduce application will be containing a mapper application, a reducer application, a combiner application, driver, helper, and custom writable applications, which you probably would have seen in the coding part, right? So this entire thing is a single jar file. What you can call is this entire thing is a jar file, so which internally contains mapper, reducer, combiner, driver, all these things. So this jar file will be invoked by this planner application through the help of this helper component. Okay, so we will see. So the planner application will contain the database where all the user information will be stored, like who is logging into our project, who is creating the job, who actually is running the job, their information will be stored along with the details of the job, like what time the job has to be executed, what is the frequency of the job to be executed, whether the weekly or monthly, all those things will be stored in the database. The concept of DAO layer, probably you people know, this is a Java application. This is a Java component which provides the database access to the outside world, right? So it too provides the data access to the outside world. Like people can insert the data into the database or read the data from the database from other components. So the meaning of UI is a wonderful UI, the front-end interface for the end user, through which he can click some buttons for registering himself. From the drop down, he can select which job to be executed, all those things. So this is the master planner where it will be executing every 3 seconds. I'll tell you what it does every 3 seconds. And this is the survey planner which will be executing every 6 seconds. So every 3 seconds the master planner will be querying the database to check if there are any new jobs being created by the user or not. If there is any new job created by the user, this master scheduler will pick it up and it will make a call to this service requester, which in turn makes a call to this analytic executor, which in turn communicates with this MapReduce application to run the job. After running the job, this result reader will read the result and it will be providing it to service requester. Okay, which once again through the UI it will be provided to the end user, right? So the meaning of admin operation is through the front end itself, the user can communicate with this component, which in turn can communicate with this Hadoop to start Hadoop or stop Hadoop, like that. Okay, so just like we have this weather data analysis, we can also have a log server analysis. Okay, so this interface belongs to the DAO layer component only, because probably in the basic training people have learned that any component should not be accessed directly, it should be accessed through interfaces. Okay, so this is the data flow diagram explanation. So now we will see the project architecture diagram. So the project architecture diagram just tells in which all layers, which all components we have written. Okay, so our entire project can be divided into 4 layer application. So if you can see layer number 1, we have database layer where all the database tables will be created. So we are using 2 tables here, job details and user details table. So here the details of the job will be stored, and here the details of the logged in user will be stored. And we are going to use MySQL for in this layer. The second layer is the Hadoop layer. So where we will be storing the mapper application, the reducer application, the driver application. So we will be using Hadoop environment given by Hortonworks Sandbox for this layer. So in the business logic layer, we are going to use JBoss, inside which we are deploying a dynamic web project as a WAR file. Okay, which contains the servlets, helpers, interfaces, utils, DAOs, and the helper components. All these things are various Java components. Okay, so in the client layer, we are just using any of the available browsers where we are coding it through Ajax, jQuery, UIKit, and Foundation framework for generating some wonderful front end. Okay, so these are the project architecture diagram you will have to remember. Okay, so now coming to the last part of the PPT, so the module wise breakdown. So the module wise breakdown is as shown here. So our entire project can be divided into 9 modules. So module number 1, we are installing that Hortonworks Sandbox and practicing sample command lines for communicating with HDFS. Okay, so in this we download and install the Hortonworks Sandbox, and also we practice some of the basic Hadoop commands like how to start Hadoop, how to stop Hadoop, and how to push the data into Hadoop, how to download the data from Hadoop, like that. So in module 2, we just understand what MapReduce is all about, like what is the architecture of MapReduce, what does it contain. So in module 3, we develop Apache log analysis. So it will be a MapReduce application where we are going to write the analytics for finding out report based on Apache logs. In module 4, we do the same thing, but it will be for weather data analysis. Okay, so we require this preliminary, basic training on Hadoop, because this is the first time people have been introduced to Hadoop. So it was not a part of our academics, neither any of the workshop or seminars that has been handled from the past 4 years. So first we need to understand what is Hadoop and what is MapReduce. So through this module 1 and module 2, so only then we can go and do the applications on Hadoop. In module 5, we do come up with the helper component. So helper component literally is a mapper between the planner and these Hadoop MapReduce applications, right? So that we are going to develop in module 5. And in module 6, we are going to generate the planner. So we have 2 types of planner, as I told you, the master planner and the survey planner. So the master planner will be developed in module 6 and the survey planner will be developed in module 7. And the front end layer, like the wonderful front end screen, will be developed in module 8, and the DAO layer, which I told you in data flow diagram, will be developed in module 9. So if I have missed this explanation in data flow diagram, so master planner is something that runs every 3 seconds to pick up newly created jobs. Survey planner is something that runs every 6 seconds to pick up any of the job that got missed or that got failed. So it's a backup planner, what we can call it as. So this is about the PPT explanation you need to present. Welcome back. So hope the PPT explanation part was clear. Now what we are going to see is I am going to show you how to install the project and demonstrate it. from the scratch, along with some high-level code explanation. So all you people will be given is a folder called Big Data Final. So inside which you can see there is a software called JBoss. It is a server on which the planner will be executing, and there will be 3 jar files. These are the 3 MapReduce applications which I was speaking about in the PPT part. One is the word count example, the weather analysis example, the log analysis example, and these 3 text files are the input for each one of these MapReduce programs. So WC input is the input for word count, logs input is the input for log analysis, weather input is the input for weather. And planner.war file is the front end layer, the UI layer, the scheduler part what I was telling. So this will be installed in JBoss, and this will be accessed in a browser. So queries.SQL is the required SQL queries. So these are the tables that we require in our project. So you can just copy and paste them in the MySQL window. Okay, so let's get started with how to install this project right from the scratch. So all you need to do is just take the Oracle VirtualBox, turn it on, and switch on that Hortonworks Sandbox. So this Hortonworks Sandbox will come by default Hadoop installed. So we don't need to bother about starting and stopping our Hadoop manually or configuring it externally. So Hortonworks does it for us. So it makes our job easier. So as soon as this Hadoop Hortonworks Sandbox has been started, you people know that you will be getting an IP address, and most of the times the IP address will be 192.168.56.101 because it will be a host only adapter, right? So for that purpose, what you can do is you can, as soon as this the Hortonworks Sandbox gets started, I don't wanted you people to use this window because this is a single terminal application which will not be used most of the time. So you just minimize it, and you need to open 3 PPT terminals. So you need to log into that using 3 PPT terminals. So I will open them. So I have taken 3 PPT terminals. Along with these 3 PPT terminals, I will also require WinSCP. So I will log into WinSCP. So there you people can see I have 1 WinSCP and 3 PPT terminals being opened. Okay, so I can go ahead and start executing the program. So the installation procedure will be like this. The first step what you need to do is you need to create a new folder. See, this left hand side happens to be the Windows file system, the right hand side happens to be the Linux file system. So under the Linux file system, I'll create a new folder called project work. So it should be everything small case and without any space in between them. It is very case sensitive. So I created a folder called project work. Inside that, you need to create another folder called jars, JARS, jars. So now if you open that big data final, the folder which I given in the Windows operating system, all I want you people to do is all the 3 jar files that I told you, weather.jar, wordcount.jar, log analysis.jar, you need to drag it and drop it under this folder called jars. So under these things we got all those 3 jar files, and then the server you need to drag it and drop it here, JBoss server. So once the JBoss server has been copied into Linux operating system, you need to extract it, because what I have given is a zip file. You need to extract it. So the procedure to extract is to go to that path, first copy that path, and then go to that using one of the PPT terminal, cd space right click. From there you can say unzip that JBoss folder. So now you people can see, if you can refresh, it got unzipped. Now you don't need this version, you can delete it. So this happens to be the second step. The third step is to push these input files into Hadoop file system. So these 3 are the input for our MapReduce applications, right? You need to push them into Hadoop file system. So you know how to create the folders in Hadoop file system, right? So Hadoop surface -mkdir I will say that IPT1. IPT1 happens to be the first input. So I'll create the second folder IPT2. I'll create the third folder IPT3. So I created 3 folders in Hadoop file system: IPT1, IPT2 and IPT3. So what I need to do is I need to move this WC input into IPT1, log input into IPT2, and I need to push weather input into IPT3. The command you people know. So you need to issue Hadoop fs-put WC input and pushing it into IPT1. Okay, spelling mistake. So I'm going to push log input into IPT2, and I'm going to push the third one, weather input, into IPT3. So the 3 inputs are ready now. IPT1 is for weather word count, IPT2 is for log analysis, IPT3 is for weather analysis. So what next? You need to just deploy this planner.var file inside JBoss and run it. But before that, you need to create the required tables for our project now. So the tables can be created by logging into MySQL -u root -. So password is nothing, simply press enter. So all you need to do is inside this query.sql, whatever you have, you need to just copy it and you need to press right click. That's it. So the required tables has been created. Now the only thing is start JBoss and deploy the planner and then run it. How to start JBoss? You need to get into JBoss bin, copy the path above, go to one of the putty terminals, cd space, go to that path. Now you need to issue a command stand alone.sh-b 0.0.0.0. But sometimes if you get this kind of permission denied, you need to go one directory backwards and you need to change the give the permission like this for the bin folder. Okay, after that now you can get into the bin folder, then start standalone.sh-b 0.0.0.0. So there you can see the JBoss is getting started. So once the JBoss is getting started, it will not give you back this terminal. It will keep it for itself. So you need to minimize it. So JBoss has been started now. You need to deploy this planner.var file inside JBoss. The procedure is to getting into the standalone folder, the deployment folder, just dragging and dropping this planner.var file. Keep on refreshing it. So you should be getting a deployed file. So if you got a deployed file, then it has successfully been created. Okay. So now it's like everything is set up ready. So now you can directly go to browser and if you the URL 192.168.56.101:8080/P planner. So if you enter that, there you can see the project gets loaded. Now the deployment part has been successful. So let's get started by registering. So I'll be registering new account called ashok@gmail.com. Password is 1234. First name as Ashok, last name as Kumar. So I'll register. It says registration successful. I'll log in now and I will log in as ashok@gmail.com. Password 1234. I have been logged in now, so you can see welcome message. And now I'll go to plan a new job. There I'll select I want frequency count, or I want weather analysis. It could be whatever it is. So I'll schedule it daily. Okay. Now if you can go to the third terminal and check the time of Hadoop. Current time in Hadoop is 5:43. So I'll schedule the job to be executing at 5:40. Anytime is actually doesn't matter. So I schedule weather analysis, right? The input happens to be IPT3. So this email address doesn't matter because we don't have that functionality right now. So I'll click on plan. So now it says successfully created a plan. So the job that we created is supposed to be executing at 5:40, but right now the time in Hadoop, if you can see, it is 5:43. So the job should already be started executing. So if you go to view all jobs now, you can see it already started executing. It is in the running stage. Okay, so you need to wait for some time, and after that you need to keep on refreshing the page to check whether it has completed or not. So there are three status of jobs actually. So the first status is called new. This is when the job has been newly created. Okay. The second status will be running. So this is when the job is in executing phase. I mean the currently the map is executing. And the third state of the job is in progress. So in progress indicates that the job has been executed at least once. The difference between in progress and new is what you know. New is the job has never been executed till now. In progress is it has executed at least once. So if you can refresh it, so now the status goes to in progress, meaning the job has been executed once. So now if you can go to the view button, so there you can see one output got generated. So if you can view that, here is the output. So here is the analysis of the report. So now if you can go back to that and check what is the input you provided. The input we provided was weather input. It was like this. So it was the weather data. So Bangalore city temperature at this date at this time. So it is a series of temperature input. So you can copy and paste it and make the input size bigger as you want. It doesn't matter. But whatever MapReduce job has done is it analyzed them and it's saying that on 21st April at 12 o'clock to 1 o'clock, Mysore is the city having the least temperature and Bangalore is the city having the highest temperature. So on the same day from 1 o'clock to 2 o'clock, Bangalore is the city with least temperature and Mysore again with the city with highest temperature. So this is how the weather data will be analyzed. Okay, so the specialty of this planner is what you know. So now if you purposely change the date to tomorrow, so I'll just change the date to 31st May 2015, 17:39, 30 seconds. So I change the date to 30 seconds. Now if you can refresh this page, view all jobs, it's still in progress because it is still 42 seconds. So if you keep on refresh, it is still be in progress. So 50 seconds. Another 10 seconds, the job will be executed again tomorrow. Okay. So it's 58 seconds. So now the job should be executing, right? If you refresh it, now you can clearly see the job has been executing. I mean, daily it will execute at 5:40. Okay, 5:40 every day. It will keep on executing the data and it will update the result with the input provided. Okay. So the amount of time taken to execute this job actually depends upon the capability of the machine. It could be either a RAM or any of the available memories and all. So you need to make sure you have some sufficient processing power in your machine. Okay. So you can see it has completed the executing now. Now if you click on view, so there you people can see we have two folders. I mean it says that the job has been executed for 2 days, one on May 30 at this time and another on May 31 at this time. So you can see the result of any day's weather analysis. Okay, so expected that the input will be changing for each day, the output also will be updated for the corresponding input. I'll create a log analysis. So I'll make it at 1750. So IPT2 is the input for log analysis, you people know. So I created a second job. Now it is in a new phase state. Because the current date, current time happens to be 1746, but this job will be executing only on 1750. So I'll send the date manually to 31st May 2050, 1750. Sorry, 1749, 50 seconds. So now the job will be executing in another 10 seconds. So it's still in the new state. So now if you check the date, it's 1750 now. Now the job gets executed. So you need to keep on refreshing the page after some time to check if it has been completed or not, because the amount of time taken in this page will directly depend on the system capability. So now the job has been completed, so you can go to view, and there you can see the output being generated. So this is the output that has been generated for log analysis, where it says that under 4 p.m. to 5 p.m. 17 people have visited the site. 5 p.m. to 6 p.m. 23 people have visited the site. So 6 p.m. to 7 p.m. only 2 people have visited the site, like that. So if you can see the input that we provided, the input was the log. This is the traditional format of Apache log server, simply saying who visited the page, at what time you visited, which page you visited, like that. So we generated the report out of it, and we are clearly showing what happened in each hourly breakdown, right? So this is how you need to demonstrate this project. So now if we can go back to the big data final folder that I given. So these are the 3 jar files, MapReduce applications that we have come across with, and this is the planner.war file. These are the coding efforts, the MapReduce applications and the planner.war file, right? So here are the coding part for that. So the planner.war file, okay, and Apache log, the MapReduce application, weather analysis is another MapReduce application, word count, another MapReduce application. As I mentioned earlier in the word count, MapReduce architecture part, each MapReduce application will be containing a mapper, a reducer, and a driver, right? So this is the mapper part of word count, reducer part of word count, and driver part of word count. So likewise, we do have mapper, reducer, and driver for log analysis, and mapper, reducer, driver for weather analysis. Okay. So now if you can go to the planner application. So planner application ideally happens to be a dynamic web project. So the meaning of dynamic web project is it will be installed in JBoss, but it will be accessed in a browser from any remote application, server-side applications, right? So this is the planner application. So the server-side application will mainly contain 2 end of operation, the front end and the back end. So anything that comes under web content happens to be the front end, and anything that comes under SRC happens to be the back end. So if you can see in the front end, we have all the JSP files, the views, the pages that are used to create the pages, like these pages and all are coming from the JSP files that are written directly under web content. And under Java, the backend business logic will be written. So if you can look at this code, there are various packages that are used in this project. One is com.aklc.util. So this package will contain the DB helper, which is used to get the connection and close the connection from the database. It will be containing the command executor, which is used to execute that MapReduce application. So this will execute any Linux command from JBoss. Okay, and we have a package called com AKLC servlet. So all the servlets will be written here. So why do we need servlet is to interact with the user. So you click on plan a new job, one servlet will be called. You click on this button, one servlet will be called. So each and every action will be processed by each and every servlet. So we have a package called com AKLC Pojo. This is a mapping. So we have 2 tables in the database, job table and the user table. So this happens to be the mapping for each of those tables, which you people would have seen in the basic training. So we have a package called com AKLC planner. So as you see, we have 2 planners being created in the architecture diagram. No? So one is the master planner and the other one is the survey planner. So master planner will be running every 3 seconds, and it will be checking for daily jobs, weekly job and monthly job, and it will be executing them. So if you can see how this has been generated, so we are taking the in progress job and the new jobs. Okay, but if you can look at the survey planner, we are taking the failed job, right? So master planner will take the new job, survey planner will take the failed jobs. Okay, we have a package called com AKLC mail for sending the notifications for the user saying that job has been executed. So we have a package called com AKLC job. So we have 3 files under it: logjob.java, wcjob.java, witherjob.java. This is to execute the log analysis, the command to execute the log analysis. This is to execute the word count, and this is to execute the weather analysis. Okay, and these jobs will be called by this helper component, so which will make use of that uh, these three jobs. And we have an executor, job executor, so which will execute those jobs. So after executing those jobs, it will update the status with either in progress. If any exception comes, it will update it with failed. Okay, so if we are executing a server log analysis, or if we are executing the word count analysis, or if we are executing the weather data analysis, inside the try block you can see we are updating it with in progress, saying that the job has been successfully executed. Inside the catch block we are updating it with failed, saying that the job failed to execute. Okay, so and DAO part you people know, these are the DAOs providing all the possible functions like reading, writing, updating, deleting, all those things. Okay, so these are the package and file level explanations you people should be remembering under the planner part. Okay, so hope this helps you people for the demonstration and the execution part. So please reach out to me on 974202406 or celestialcluster@gmail.com if you have any queries. Okay. Thank you guys. All the best for your examination.